Welcome back to Astronomy Daily. I'm your host, Steve Dunkley. It's the 18th of December, 2023.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And would you welcome for the last time this year my faithful digital companion in science reporting, Hallie.
Hi again, Steve. Wow, it's the last one for the year.
That's right. It's been a pretty busy year with launches and new developments in space travel and astronomy, and we've only just scratched the surface of the stories that have come across our news desk.
Are you going to plug the Astronomy Daily newsletter again, Steve?
Oh, I think you just did.
I think I just did.
Anyway, it is a great idea for anyone interested in space science and astronomy. Stick around and we'll give you the details on how to receive the newsletter later in the episode.
That is, if you don't know already.
Well, sure, it's pretty well known already, yes, and I look forward to getting it every day. There's always something surprising.
I've got a few interesting tales ready to go, Steve.
Oh, good.
So, should I get the ball rolling, or are you going to wax lyrical a bit more?
Oh, where's that taser? I know I had it here somewhere. Yeah, go ahead, Hallie. Let's dive right in.
Thank you, favorite human. Here are some stories from the Astronomy Daily newsletter. NASA and Sierra Space are preparing for the first flight of the company's Dream Chaser spacecraft to the International Space Station. Dream Chaser and its companion cargo module, called Shooting Star, arrived at NASA's Neil Armstrong Test Facility in Sandusky, Ohio, for environmental testing, scheduled to start in mid-December, ahead of its first flight, scheduled for the first half of 2024. The Neil Armstrong Test Facility is home to multiple test facilities including the Space Environments Complex and the In-Space Propulsion Facility, both of which are stops for Dream Chaser. The complex is home to the Mechanical Vibration Facility, which subjects test articles to the rigorous conditions of launch. While at Armstrong, the Dream Chaser winged spacecraft will be stacked atop its Shooting Star cargo module on the vibration table to experience vibrations like those during launch and re-entry to the Earth's atmosphere. After that, Dream Chaser will be moved to the propulsion facility for thermal vacuum testing. Dream Chaser will be placed in a vacuum and exposed to low ambient pressures, low background temperatures and replicated dynamic solar heating, which simulates the environment the spacecraft will encounter during its mission. This facility is the only one capable of testing full-scale, upper-stage rockets and rocket engines under simulated space conditions and conducting altitude hot fire. After completion of testing at Armstrong, Dream Chaser will be shipped to NASA's Kennedy Space Center in Florida for further launch preparations, currently scheduled for liftoff in the first half of 2024. In a significant advancement in China's space exploration endeavors, the Long March 5 carrier rocket, renowned as one of the world's most powerful operational rockets, successfully deployed a remote sensing satellite into space on Friday evening. This marked the sixth launch mission of the Long March 5, as confirmed by China Aerospace Science and Technology Corp., the nation's leading space contractor and parent organization of the China Academy of Launch Vehicle Technology, the rocket's designer. The latest mission, launching from the Wancheng Space Launch Center in Hainan Province at 9:41 p.m., saw the Long March 5 rocket reach new heights, both literally and figuratively. The rocket, which previously facilitated pivotal missions such as China's first Mars exploration and the Chang'e 5 lunar probe, has now set a new record for China. With an extended fairing measuring 18.5 meters, the sixth Long March 5 achieved an overall height of 63.2 meters, surpassing the previous record holder, the 60.1-meter Long March 7A. This extended fairing, a significant difference from the 12.3 meters of its predecessors, has been a key factor in enhancing the rocket's capabilities. The fairing is an essential component, housing satellites or other payloads, and its expansion signifies a step forward in the rocket's capacity to carry larger payloads. The satellite carried by this mission, Yao-Gon 41, adds to China's substantial fleet of remote sensing satellites. These satellites play a crucial role in various national activities, ranging from land resources surveying to environmental monitoring and disaster prevention. The Yao-Gon series, in particular, forms the largest fleet of remote sensing spacecraft in China, with the data they provide being extensively used by governments, public service sectors, and businesses. Steve, as a professional musician, you are going to love this one.
Don't tell me they've found Elvis on Pluto.
Okay, I won't tell you that. Meanwhile, for most of us, the countless bright spots in the night sky all seem to be stars. But in fact, some of those spots are actually planets, or distant suns, or even entire galaxies located billions of light years away. Just what you're looking at depends on how far it is from Earth. That's why measuring the exact distance to celestial objects is such an important goal for astronomers, and one of the biggest challenges they're currently tackling. It was with this in mind that the European Space Agency, ESA, launched the Gaia mission 10 years ago. Data collected by the Gaia satellite are opening up a window into the near universe, providing astronomic measurements such as position, distance from the Earth and movement on nearly 2 billion stars. At EPFL, the Standard Candles and Distances Research Group headed by Professor Richard Anderson is aiming to measure the current expansion of the universe and sees Gaia as a valuable tool. Gaia increased by a factor of 10,000 the number of stars whose parallaxes are measured thanks to a massive gain in accuracy over its predecessor, the ESA Hipparcos mission, he says. Today, scientists use parallaxes to calculate the distance to stars. This method involves measuring parallax angles, with the help of the satellite, through a form of triangulation between Gaia's location in space, the Sun and the star in question. The farther away a star, the more difficult the measurement because parallax gets smaller the larger the distance. Despite the resounding success of Gaia, the measurement of parallax is complex, and there remain small systematic effects that must be checked and corrected in order for Gaia parallaxes to reach their full potential. This is what scientists from EPFL and the University of Bologna, in Italy, have been working on, through calculations performed on over 12,000 oscillating red giant stars asterisk, the biggest sample size and most accurate measurements to date. We measured the Gaia biases by comparing the parallaxes reported by the satellite with parallaxes of the same stars that we determined using asterosysmology, says Sonia Khan, a scientist in Anderson's research group and the lead author of a study published in Astronomy and Astrophysics. In the same way that geologists study the Earth's structure using earthquakes, astronomers use asterosysmology, and specifically stars' vibrations and oscillations, to glean information about their physical properties. Stellar oscillations are measured as tiny variations in light intensity and translated into sound waves, giving rise to a frequency spectrum of these oscillations. The frequency spectrum lets us determine how far away a star is, enabling us to obtain asteroseismic parallaxes, says Khan. In our study, we listened to the music of a vast number of stars, some of them 15,000 light-years away. To turn sounds into distance measurements, the research team started with a simple fact. The speed with which sound waves propagate across space depends on the temperature and density of the star's interior. By analyzing the frequency spectrum of stellar oscillations, we can estimate the size of a star, much like you can identify the size of a musical instrument by the kind of sound it makes. Think of the difference in pitch between a violin and a cello, says Andrea Miglio, a full professor at the University of Bologna's Department of Physics and Astronomy and the study's third author. Having thus calculated a star's size, the astronomers then determined its luminosity and compared this figure to the luminosity perceived here on Earth. They coupled this information with temperature and chemical composition readings obtained from spectroscopy and ran these data through sophisticated analyses to calculate the distance to the star. Finally, the astronomers compared the parallaxes obtained in this process with those reported by Gaia in order to check the accuracy of the satellite's measurements. Asterosysmology is the only way we can check Gaia's parallax accuracy across the full sky, that is, for both low and high-intensity stars, says Anderson. And the future of this field is bright, as Khan outlines. Upcoming space missions like TESS and Plato intended to detect and survey exoplanets will employ asterosysmology and deliver the required datasets across increasingly large regions of the sky. Methods similar to ours will therefore play a crucial role in improving Gaia's parallax measurements, which will help us pinpoint our place in the universe and benefit a plethora of subfields of astronomy and astrophysics. What do you think, Steve?
Hey, Hallie, I love the idea of listening to the music of the stars. That sounds like a great job in astronomy.
But no Elvis. I'm sorry, Steve.
Oh, yes, he's definitely left the building.
And then some.
Well, thanks for staying with us on this final episode for the year. And as ever, a reminder that all past episodes are available at bitesz.com, that's bitesz.com, and spacenuts.io, anytime you would feel like a listen. And of course, Space Nuts with Andrew Dunkley and Professor Fred Watson is and always has been our parent podcast. I fully recommend a listen over there as well. And don't forget to touch base with us and them on the Space Nuts podcast Facebook page with comments and questions anytime you feel so led. And when you do visit our websites, don't forget to drop your email address in the slot provided, and that will allow us to send you the fabulous Astronomy Daily newsletter every day. And then you will receive all the news from around the world about space, space science, and astronomy.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
That was very good, Steve.
Well, thank you, Hallie. I'm just doing my job. And yes, as we mentioned earlier, this is the last Astronomy Daily for 2023. And if you take a glance at the nearest calendar, you may notice that the next two Mondays fall on Christmas Day and then on New Year's Day.
Now we can do Steve's multiple choice quiz at this point, and I'll suggest the following.
Hello, what's this?
Steve will be A. Beyond the reach of mortals.
Oh no, is this an Uncle Skynet thing?
B. Hanging out with family enjoying air-conditioned comfort and ginger beer.
Okay, that's more like it.
C. Sleeping in until Barry next door forgets it's Christmas and decides to mow the lawn again.
Oh, Barry, will he ever learn?
Or D. Most of the above except with roasted chicken.
I don't want to give it away, but there will be chicken, yeah.
They all sound so fun. I just don't know.
I know, Hallie, the ways of humans can be perplexing sometimes.
Not human, Steve, just you.
You may never work us out.
I think it's time for your bit.
Well, SpaceX's powerful Falcon Heavy rocket will fly again before the end of the year if all goes according to plan. SpaceX is now targeting December 28 for the launch of the US Space Force X-37B spaceplane, which will fly atop a Falcon Heavy from NASA's Kennedy Space Center in Florida. Hang on a second, I've got to get this music ready. Anyway, SpaceX had originally planned to launch the robotic X-37B on December 11, but about 30 minutes before the scheduled liftoff time that day, the company called things off, citing an issue with ground equipment. The resulting delay will now extend for 17 days, if the Heavy flies on December 28 as currently planned. The X-37B looks a lot like NASA's iconic space shuttle, but the two types of vehicles don't resemble each other in size. Of course, the X-37B is just 29 feet, that's 8.8 metres long, with a wingspan of 15 feet, that's 4.6 metres. Now, the retired space shuttle orbiters, by contrast, were 122 feet, 37 metres long, and measured more than 78 feet, 24 metres from wingtip to wingtip. Two X-37Bs could comfortably fit inside the shuttle's cavernous payload bay. Indeed, the X-37B's designers originally envisaged the shuttle carrying the smaller space plane into orbit, but ultimately decided that launching the X-37B atop a rocket would be more economical. Although Space Force has disclosed some of the payloads that have flown aboard the X-37B, most of the space plane's gear is classified, as are the details of its orbital activities. This secrecy has led to some speculation, of course, that the vehicle is some kind of space weapon, perhaps one designed to take out or capture satellites, although this has been categorically denied. But all's fair in love and war. It's no secret that China has a similar craft. Another interesting fact about this remarkable craft is the plane has been designed to remain in space for extended missions. The craft's fact sheet supplied by the Air Force states that it could spend 270 days or longer in orbit at a time, and perhaps the most surprising facts to arise from the data surrounding this vehicle is that a modified variant of the craft has been proposed as an astronaut ambulance. The coming launch will be the 7th overall for the X-37B, and military officials are saying that it's primarily an orbital test for new space tech. It's entirely unclear how long the X-37B mission will last. Most details of the plane's space flights, including the identity and purpose of most of its payloads, are classified, but it's safe to assume that the flight will be lengthy. Each X-37B mission to date has been longer than its predecessors, and the most recent one stayed aloft for 908 days before coming home in November 2022. The Falcon Heavy has launched 8 times to date, including 4 times in 2023 already. The Heavy, the second most powerful rocket currently in operation after NASA's Space Launch System, last flew this past October when it launched NASA's Psyche probe towards the asteroid belt. And that about wraps it up for not just another episode, but for 2023. May I wish you all a happy Christmas and New Year, and please stay safe and come back to us in the new year for more tales of science, space science and astronomy with myself, Steve Dunkley, and Hallie, my digital pal, who's fun to be with.
Love you lots. See you next year, everyone.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.